Hello everybody, this is Andrew Trolson. I am an instructor here at Intertech, and what I want to do in this video excuse me, is to give you kind of a little taste of our complete WPF class. Now you can see on the screen right now I've put down the words short form. This is kind of a condensed version of the full chapter 1 of the class, and the reason it's condensed is because if I were to lecture over all the material and kind of walk you through all the labs, that takes a pretty good part of the first day of class. And I'm sure you don't want to be online with me for 5 hours or whatever, so we won't be doing that. But what I do want to do here is to kind of set a foundation for you so you understand the nature of WPF and you also understand some of the details of working with the programming model. So what I want to do is fire up, and I'll be going back and forth between PowerPoint and a couple of different demos. We'll talk about Expression Blend, I'll talk about Visual Studio, I'll kind of talk about some of the syntax of Zamel itself. So why don't we just kind of get right into it here. Now, historically speaking, if you've worked with any of the Microsoft UI toolkits in the past, whether it be MFC or VB6 or Windows Forms, they were all essentially just wrappers around some of the real basic Windows operating system primitives, like User32 and GDI. And that's okay, but under these older models, what we typically would find is that when you wanted to build up a full-scale, feature-rich desktop application, you had to wear some very, very different hats, right? Let me just skip to this slide here and then I'll go backwards, but let's look at this little chart right here. This is kind of the way things used to be, right? If we wanted to build up some basic main windows, we had to pick a toolkit. And if we wanted to throw in some graphics, well, we had different toolkits, and they both had very, very different programming models. So, the way that you would write code to do DirectX 3D, wickedly different programming model than just making a dialog box with Windows Forms. So the basic idea here is that before we had WPF, things were pretty asymmetrical. Now, with the release of .NET 3.0, some time back, and continuing forward, Microsoft gave us another alternative called Windows Presentation Foundation. Now, this is an alternative toolkit. It has nothing to do with Windows Forms. That doesn't necessarily mean that Windows Forms is obsolete. Windows Forms can still be a nice choice if you want to kind of quickly pull together a smaller, simple business application. I don't mean simple as in trivial, but I just mean you don't need any glitz or glam, right? You just want to have your menu, your status bar, maybe a grid full of data. You can put that together very quickly in WPF as well, but where WPF really shines is where you want to start to incorporate these richer features like streaming video or 3D graphics. If you want to start to do customization of control content, that can be done extremely quickly under WPF without the need to subclass different parent classes, for example. And I'll kind of touch on that topic a little bit later on. So here's the way that things are nowadays. Okay, here's the same general chart, but notice now, no matter what you need, WPF is kind of a one-stop shop. Now this is good because now things are much, much more symmetrical, right? So the programming model that we use to do 3D graphics, or to work with a PDF style document, or just make a traditional main window, we're all going to use the same toolkits now. So the same programming model, we have the same use of Zamel, which is strictly speaking not mandatory, but very, very useful. So the good news for us is, if you start to climb that WPF learning curve, once you kind of get the basic building blocks figured out, you're going to find that it's very easy to just roll in new functionality as opposed to the previous model where we were constantly flipping our hats on and off. Well, let's talk a little bit about this Zamel feature, all right? It's pretty easy to think at the beginning that Zamel is just about describing a GUI. Now, certainly that's where Zamel can be really, really helpful, but understand that, strictly speaking, Zamel can be used to describe any .NET object provided that it has a default constructor. and there's not as much support for generics as we might hope. But those two things aside, anything can be described in markup. So if you wanted to, you could describe a system.string. You could describe in markup a custom collection that you wrote, or a custom business object. Okay, so it doesn't have to have a visible user interface. And also be aware too that XAML is found in places beyond WPF. If any of you have looked at Windows Workflow Foundation, under 4.0, that's all driven through XAML as well. Same thing for the XML paper specification. That's working on a XAML dialect too. So we'll be focusing here on the WPF XAML, but if you understand the basic building blocks, you'll find it pretty easy to look at Silverlight code or Windows Phone 7 code and get a pretty quick idea as to what's going on there. Now, essentially all XAML is it's an XML-based grammar which allows us to describe an object. Okay? The big motivation for this is for a separation of concerns. So this is good. Now, if any of you folks have worked with ASP.NET in the past, things are going to feel eerily familiar. We're going to have one file that describes the way things look and feel. That would be the XAML file. And then typically, the XAML file is going to be paired up with a code file. And that's where we can describe all the functionality of how it operates. Right? So we have a nice separation of concerns. Now, the cool thing about WPF, though, is that the separation of concerns is also carried out to the tool level. Right? Now, if you wanted to, you could completely stay within the confines of Visual Studio and write all your WPF programs there. Now, I'll be perfectly honest. That was my mindset a couple years ago. I was pretty happy just typing in the markup, typing in the code, kind of rolling my own solutions. But then when I started to do some more complicated things, like building control templates, or working with animations, or trying to put together graphics through markup, well, then things became really, really tedious. Even in Visual Studio 2010, we still do not have all of the built-in editors and wizards that would be really, really useful to kind of get us more productive. So eventually I finally decided to check out this complementary product called Expression Blend. Right? And nowadays I am a true believer. I've drank the Kool-Aid, if you will. Expression Blend is a Microsoft product which is really here for one primary reason. It will be generating all the XAML for WPF, Silverlight, and Windows Phone 7 projects for you. All right? Tons of built-in editors and wizards and animation tools that will just take a lot of the tediousness out of authoring the markup. Now the cool thing is, and some of you might know this directly, but an Expression Blend project is the exact same file format as a Visual Studio project. So you can open up the same body of code in either tool. And then you can kind of maximize the tool's strengths, right? XAML's the best choice if you have to put together really sophisticated markup. That's what Blend's all about. If you want to put together all the deep, deep code, well, that's what Visual Studio is all about. So these two things work together as a complement. Okay? And I'll let you show you Expression Blend in a little demo here pretty quick. Now, XAML is not the only interesting feature of WPF. Here's a hit list of some of the cool things that are baked right into the API. Let me just kind of skate over some of these interesting topics. One thing that you'll notice right away, which is very, very different from Windows Forms, is that layout is king. WPF has many different layout managers. We have grids and stack panels and dock panels and canvases. And we typically find that we start to build nested layout systems. So we have a very, very precise control model where we can say, I want this part of my window to look like this, but I want this part to dynamically resize, and I want these things to stack on top of each other. This is very simple to do under WPF. Another nice feature is that there is built-in support for styles. Now this is also kind of similar to ASP.NET. if any of you guys have worked with server-side styles, we have a similar flavor here under Windows Presentation Foundation. And certainly styles are covered in detail in the full WPF course that we teach here. I'm not going to go into that today, but there is some pretty interesting things you can do with these styles. You can make them interactive. So you could build a style that says things like, if the control using my style has focus, make it animate like this. Or if the mouse is over the control which is using my style, make it do that. So it's much more than just simply saying font size is 12 and font family is this and so forth. We can really get these things to have a real interactive life. Now another great thing is that everything under WPF is rendered with vector graphics, and that includes the controls themselves. Now this is great. This will make your life a lot simpler when it comes to things like resolution, and it also allows you to apply graphical transformations to anything. If you had, for example, a stack panel of controls, and you wanted to say, if the user clicks on this button, take that whole stack panel of controls and render it out at a 45-degree angle, maybe to like show the illusion of depth, that can be done in 3 lines of Zamel. Not kidding. And the cool thing is, you don't have to write any kind of code to recalculate hit testing or to capture when a control has focus. All that's being handled by the subsystem. Now, this thing is pretty interesting right here. Adobe PDF style documents, right? Very, very feature-rich text. Well, WPF uses a PDF-like API, which is based on the XML paper specification. Now, your average end user is not going to know the difference. It's going to either, whether or not it's an Adobe PDF file or an XPS file, it's going to look pretty much the same. Extremely rich text. The cool thing about how WPF does it, though, is that that extremely rich text can be described right through Zamel, right? So if you wanted to incorporate PDF-style functionality into your program, real simple to do that. There's even, for example, a built-in sticky notes API. So if you want to let the user select a body of text and make a little sticky note that can be saved out later on, that's simple to do as well. WPF has tons of support for graphics and animations. And I want to just speak on that for a little bit because, a lot of people that are coming to WPF classes, they're writing business applications. And that's awesome, right? That's what we do all day long. And so it can be a little bit of a confusion point, right? A lot of people think to themselves, well, I don't care about animations because I'm just going to be building a window with grids full of data, and I'm talking to web services, and we're talking to databases. I don't need animations. Well, believe it or not, you actually do. You see, animations in WPF, it doesn't necessarily mean you're trying to have a walking stick figure or a bouncing ball or a Pac-Man video game. I mean, you could do that, but animations in WPF are much, much more subtle. All an animation really means is you're changing the value of a property over time. So you might say, over the period of 5 seconds, change the background of that control from a dark blue to a light blue. Just some little visual effect, right? Make it look like it's kind of glowing. Well, that would be an animation, right? If you start to build custom templates or custom styles, which is very, very common in WPF, well, they're all about graphics and animation, right? So don't be fooled. Even if you're squarely focused on traditional business applications, graphics and animations are going to be a big part of your daily life. Now, let's take a look at a couple of examples of a WPF program. And I'm going to actually pull up Expression Blend here and show you a couple of samples to give you a better idea of what you can do with this. Right? So let me go into Blend right now. Now, by the way, Blend is actually a member of a family of products called the Expression family. You might be able to see here there's a couple of different Blend products. Expression products. I have Blend, Design, and Web. Now, for what we're doing here in this video, I'm just going to stick to Blend. Now, in the WPF course, there's actually a lot of demos on this product so that you really can kind of learn the lay of the land. Here, like I said, I'm just going to kind of open up a couple of samples. So I'm just going to go under Help, Welcome Screen. And there'll be a sample tab over here. Now remember that Blend can be used to build WPF or Silverlight applications. So some of the sample projects are WPF and some of them are Silverlight. But remember, they're kindred spirits, right? They're both based on the same core technology set. So maybe, let's see, why don't we see what path layout does. I've actually not opened this one before, so this will be new to all of us here. Alright, so this looks like it's going to be a Silverlight application. So I'm going to run the program. So you can see my browser popped up here because we're a Silverlight application. Okay, so what do we got here? Text. Okay, so what is basically showing us here is how it's possible to incorporate these graphics, right, with animation. So here might be something which is much more fanciful, right? Classic animation. We have an image following a path. We have, you know, some wave effects happening. But over here, okay, here are some animations on a more business scale. Did you see what just happened there? Let's see if I can get that to reanimate. I'm not sure what I have to click on here. Let's go back over here. But now watch that graph again. See, maybe you just did a database read here, and you want to go ahead and show the data in a visual format, which is all great. But you want to have just that little bit of eye candy, right, to kind of capture the user's attention. You know, there would be a great example. So it was actually pretty good luck that I pulled up this application. Great example of, you know, yeah, classic animations here, but animations can also be much more subtle like this, just to add some more professionalism. Now if we go to the Blend artboard, I can actually view all the markup that is being used to construct all of that. So I'm just going to go here to the Zamel viewer. Now here's the case in point. Okay, ask yourself the following question. Here we got a storyboard, which is fairly lengthy. Let's see, where's the end of this storyboard? Yeah, we're still going here. That's quite the storyboard. There it is. Okay, this whole thing is controlling some animations. Visual Studio has no support to visually design an animation. So if you wanted to use only Visual Studio and you wanted the same output that we just saw, you're typing all this. And I don't know about you, but that does not look like my idea of a great day at work, right? Let me just show you another sample here that I have used before. I'll go back to the welcome screen. So let's do... how about PC gaming? This is also another Silverlight application. So I'll just hit Control F5 to run the program. So again, we can see these nice little animation effects. Notice as I put my mouse over one of these items, I get a little pop-up. Well, that's also controlled through Zamel. There's actually a way to apply these graphical transformations to items. So if I click on something, you can see it just kind of bubbled out. I can go back to the main wheel, right? Now, you know, could we build these types of applications without WPF or Silverlight? Absolutely. But if we were going to be using a traditional toolkit, we would be writing reams and reams of code. And the part that's really so impressive is that a majority of all that graphical flair is being driven through this markup. Here's another example of an older Blend demo. It's kind of like a 3D rendered motorcycle. And if you click on any one of these little orange circles in the bottom, it becomes this spinning, rotating button. And whatever you click on, this 3D rendered motorcycle will kind of spin and flip to show you the thing you just clicked on. right? So that was a pretty good demo they had back in the day of just showing how much functionality we can actually get out of this expressive XML-based grammar. All right, now let's talk about something a little more practical. We have in WPF support for a number of different types of projects, right? And based on which type of project you want to build, you're going to have different fundamental core types. Now, if you're trying to build a traditional desktop application, main window, dialog boxes, maybe you want to deploy it through an MSI installer, or maybe just an Xcopy installation, well, then, at bare minimum, and I'm talking bare minimum, you need to make use of two types, the window class and the application class. Now, if you have a background in Windows Forms development, you can kind of think of window as the new form. Even though Windows Forms had an application class as well, this is a completely different one, which we subclass. You might remember back in Windows Forms, all the functionality was static. Okay. Now I'll show you a little demo using those two classes to build up a simple application in just a minute. We also have a different type of application, which is called a navigationally based application, or just simply a navigation app, right? What a navigation app allows us to do is to superimpose on top of a desktop executable this web-like navigation structure. So here's a screenshot of the, I think that was actually back when I had Vista installed, but looks pretty similar on Windows 7. This is just the Windows Explorer, right? So using this navigation model, there's a class which is actually called Navigation Window. Navigation Window is a window which also has the ability to display this little history list, right? A navigation window is the container of page objects. And essentially what a page object is a very lightweight window that cannot be displayed on its own. It has to be put inside of a container, one of which is called the navigation window. Page objects, though, can also be put inside of these containers called frames. They can also be hosted by a browser. And if you have page objects that are hosted by a browser, you have one of these guys. You have an XBAP. Okay? An XBAP is sort of like a re-envisioned version of a really old technology some of you guys might remember. There was a technology years ago called an ActiveX document. Cool idea, basically hosting a form in a browser, but it just didn't work all that great. Well, think of an XBAP as an ActiveX document done correctly, right? When you are building an XBAP, what you're essentially doing is you're going to be hosting a bunch of page objects under some dedicated virtual directory, right? The end user is able to navigate to that URI, and what gets sent over to them is this little XBAP, right? Which is basically a zip file, and inside of there is going to be a collection of compiled pages. And then the browser will host those inside of itself, right? Now, the great thing about XBAPs is that we're basically building a WPF project. So we can have the same level of sophistication inside of the browser that we might have on the desktop. Now, there's a couple of drawbacks, though, right? The machine which is viewing the XBAP has to be a Windows machine, so this is not going to be cross-platform, because the client machine has to have the .NET framework installed. And not every single browser in the world is going to work. They did just add support for Chrome. Okay, so Chrome is also in that list now. But for an in-house application, XBAPs can be great, right? Because then you can get a very simple deployment model, very easy to update things. You just got to plop in your new XBAPs and pages, and the user has that web navigation experience. Now, to make things a little more confusing, we have Silverlight. And at first glance, Silverlight and XBAP almost appear to be in some kind of weird competition, right? Well, here's the big point of differentiation. Remember that Silverlight is based on WPF technologies. But the key is, it is actually cross-platform. All right? Microsoft has built up a Silverlight runtime for Mac OS, and of course Windows is also supported. Okay? Now there's actually more support than just this, and I'll mention that in just one second. Now the thing which is also fairly different is that whereas an XBAP typically takes up the entire real estate of the viewing area in the browser, a Silverlight application is typically meant to be a smaller part of a bigger website, right? You know, think of Silverlight as basically Microsoft's competitor to Adobe Flash. Now, if you're interested in Silverlight, I would direct you to the official website. Just go to silverlight.net. You know, here you can go ahead and download the latest project templates for Visual Studio, and you can also see a whole host of different sample applications. Now, the cool thing about coming to this particular class, by the way, is that as you're learning WPF, you're also kind of indirectly learning Silverlight, because again, they are based on the same core programming model. They're not identical, but they're very, very close. Alright, now that extra bit I wanted to point out real quick. Let me just fire up my web browser for a minute. Some of you may have heard of a open source .NET framework called Mono. Mono-project.com. Well, the Mono team has built up something called Moonlight. Okay? Moonlight is an open source version of Silverlight, and this runs under Linux-based operating systems. So now, believe it or not too, they actually have support from Microsoft with this, right? So they were actually able to kind of work with them to build up Moonlight. So just like an Adobe Flash applet can be hosted on multiple operating systems, same thing with Silverlight. Now, obviously, we're not going to go into that here, but just like to point that out to people. Okay, now, let me talk about this other little bit here, too. WPF is a big, big technology. Tons and tons of things you can get into here. And the help system is really, really useful. If you've looked at the latest help system for .NET 4.0, you're aware that it's now all web-based. So even if you're running your help system on your local machine, it's going to be hosted up in a web browser here. Why don't I just open up the help system to show you the WPF area. So we can just come under .NET Framework 4. And then there'll be a link here for WPF. And here's all the good stuff, right? Notice, for example, there's a whole area just on different flavors of data binding. I can get full information about graphics and multimedia, 3D graphics overview, right? Tons and tons of different things that we can look at. Lots and lots of different samples to grab. So it's definitely worth your while to make sure that you spend time in the documentation. This will really help give you a full picture of what you can do with this technology. Now, let's get to some code. Not too surprisingly, WPF is really nothing more than a new set of assemblies. And within those assemblies, we have a collection of different namespaces. Again, no surprise to experienced .NET people. Really, the crux of the functionality for WPF comes from these three libraries here: Windows Base, Presentation Core, and Presentation Foundation. Now, when you make a brand new WPF project with Visual Studio or Blend, you're going to get references to those automatically. Now, here's a subset of some of the namespaces that you'll be bumping into. Let me just kind of pull out a couple of key ones. System.Windows is the root. Inside of there, you'd find, for example, the application and the window class. We have a number of different namespaces that package up different controls, but this is the primary area. This is where you'll find all the controls for menu systems and buttons and list boxes and so on. This guy here is pretty interesting. There are ways to programmatically manipulate Zamel. You can load it up, you can save it out at runtime. And that's actually a lot more useful than one might think. You could say, for example, you have 5 Zamel files that are describing 5 different ways the window could look. And maybe when the user clicks on different buttons, you're going to dynamically restyle the layout of the window. Well, you could do that by having this ability to dynamically read in the markup. Now, as an alternative, you can also read in the binary version of Zamel. Here's another little goofy term for you, BAML, right? Zamel, well, that's what we saw back there in Expression Blend, right? That XML-based grammar. Well, when you compile the actual application, you never have to ship the Zamel files. All that markup is going to be condensed down into a binary format called BAML, and it's going to be embedded in your assembly as an application resource. Notice how we have a namespace devoted to that navigationally based application. And believe it or not, this guy right here, this one is going to be probably one of your favorites, because this gives you the ability to work with interactive vector graphics, system.windows.shapes. Now, let's think about where that could be so useful, right? Let's say that you want to build a custom control template to completely restyle how the button looks. A template, by the way, if you haven't played around with WPF before, every single control has what is called the default template. And that just means the set of instructions that tell the control look like this by default, right? So the default template of a button, it would just be your traditional gray rectangle. But if you wanted your button to look like a yellow star, you could define a template in Markup that defines the boundaries of a star, and you could use, for example, a polygon for that, right? Well, the cool thing is now, is if you want to interact with that polygon, all you have to do is handle normal everyday events, right? So you could handle mouse down, mouse enter, mouse up. And the great thing is that the actual WPF subsystem, it's going to go ahead and only fire out these events if your mouse cursor is in the boundary of the polygon, not the larger bounding rectangle. So things that used to be really, really hard to do, like hit testing on graphics, is now really, really easy to do. I can maybe just give you a quick little demo on that. Maybe I'll give you a little extra demo too, just to really show you some cool stuff. This is outside of what I normally would talk about in Chapter 1, but what the heck. This is something I talk about in Chapter 3, actually. Alright, so remember we have Expression. That's a family of products. I'm going to open up this other product here called Expression Design. Now, Expression Design, this is definitely a tool for a graphical artist. This is kind of like Microsoft's version of a Photoshop or an Illustrator. Now, I'll admit readily that I'm not a graphical artist. So I'm just going to pull up a sample. I'm going to grab the teddy bear. So imagine that a graphical artist just put together this image. And you said, hey, you know what? I would love to take that teddy bear and bring it into my WPF program. And I want to interact with it. So maybe if they click on the eyeball, I want the eyeball to spin around in a circle. I'm going to actually resize this so I can export it a little more cleanly. Right, so there's my little teddy bear. Well, if you don't care about the interactivity, the graphical artist could just export this out as a TIFF or a JPEG or a bitmap and be done with it. But if you want to interact with this thing, you can actually export the image. I can pick export instead of import. Export the image in Zamel. So now this is actually extremely compelling. This would allow you to bring this markup into a WPF program, give names to the objects you want to give names to, then you can drive those things through code or markup. So I'm just going to export this little teddy bear. I'm just going to put it on my desktop so I can find it easily. Notice I picked a WPF canvas, and that's it. Now, let's go to my desktop. So there's my XAML file, right? And I'm going to actually open up this teddy bear in a new expression blend project. So I'm just going to go File, New Project, WPF application, call it the bear demo. And let's put that on my desktop as well. Now, watch this. I'm going to add an existing item to my project. Let's go back to get the teddy bear. Okay, check it out. Here is the bear in Blend. Now remember, this is not just a straight JPEG. All these things are objects. So I could now click on different parts of this bear, right? Like there's the ear, right? Got the nose, part of the mouth. And I can now interact with all these things through code. So this is actually wicked cool, right? So if I wanted to go ahead and say things like, well, if they click on this particular item, I could just come over here. Well, I didn't put it into a code file yet. But I could just come over here and handle a mouse event and then do something to that particular item, right? So you can see these are all movable pieces now, right? Because I was able to break down this bear into markup. So some really interesting interactions between graphical designers and programmers, right? I mean, how many times have you had some sort of a graphic and you wanted to hit test a certain thing, right? Like if they click on this part of the company logo, I want to animate it with a spinning globe or who knows what you're doing. Well, now that kind of stuff is significantly easier. So a little bit of a tangent there, but thought that was pretty fun to show you. And so that just really kind of illustrates back what we were saying over here about system.windows.shapes, right? Interactive graphics. Now let's go ahead and come back to the code, right? What I want to do next here is I want to illustrate how you could build a fully functional WPF program without any trace of XAML. You know, strictly speaking, XAML is always optional. If you can describe it in XAML, you can describe it in code, right? Now, most applications are going to have a combination of both, but it's not mandatory. So let's just build a simple window here using the application and the window. Now, the application class, this is just an abstraction of a running WPF program. So you never see this on the screen anywhere, right? He's kind of doing that lower level set of services like routing messages to where they have to go. It's also commonly used as a location to package up global data for the whole application. And it also has a series of events like dispatcher unhandled exception that you can intercept. So here's just kind of a breakdown on some of the core members of the application class. Now remember, you actually subclass application. You're not going to be calling everything statically. There are some static members, like current is static, but a majority of all these things here are instance level, right? So again, real quick hit list here. Notice how the application maintains a collection of every window currently in memory for that particular application. So it's really simple to do things like, you know, enumerate all the windows and minimize everything. Or find the window with this title and close it. That's pretty simple. Properties. This is where you can package up those global pieces of data that all windows can make use of. You know, maybe it's a connection string. Maybe it's a custom collection of business objects. Maybe it's a blob of XML data. You can just package it up there. And then these three events, those are pretty much going to be handled all the time for every application. Startup, exit, dispatcher, unhandled exception. I'm sure you can guess what you would do inside of startup and exit, right? You know, start up the application and then shut down gracefully. But dispatcher unhandled exception is really, really nice. What this event allows you to do is to catch any exceptions that you did not directly catch through a try-catch block. So if some unhandled exception is raised, this is your last chance to deal with it before the user sees that really ugly default error dialog box. So here would be a super simple application. I'll show you a full one in just a few slides, but you can see that I've written a class which extends application, and that's where we typically will be packaging up the main method, right? So inside of there you could handle those events that we mentioned, get the first window on the screen, and then you just kind of sit there in the background waiting to eventually terminate. Now notice how the main method has been decorated with STA thread, right? Single threaded apartment. For any of you COM people out there, this is actually mandatory. If you forget to decorate your main method with STA thread, you're going to get a runtime exception. This just makes sure that if your WPF program is using any legacy COM objects or ActiveX controls, they're going to be thread safe automatically. Now thankfully Visual Studio and Blend always put that attribute there for you. Just make sure you don't delete it. Now as far as the window class goes, don't worry, I'm not going to walk through every single piece in this little quick video. But I do want to point your attention to maybe the most interesting of all of these parent classes. And that would be content control. WPF and Silverlight and Windows Phone 7, they all support this really interesting model called the content model. Now, from a simple definition point of view, you can think of content as whatever is inside of the interior of a control, right? That's not strictly the prim and proper definition, but that'll serve our purposes here. Now usually when we think about content of a control, things are very kind of vanilla flavored, right? A button has string data as content. A list box has a collection of strings as list items. Well, with this idea of content, you can plug inside of a control whatever you want to put there, right? So if you wanted to say, well, my button actually has an embedded stack panel, and in that stack panel I have some graphics, 3D animation, and text. You could put that inside of your button. Now the content model is our very first step in customization. If you wanted to make a button like this, in any other framework, Windows Forms, MFC, what have you, Java Swing, you'd need to subclass, right? You'd probably have some new class, which is a button. Then you'd be overriding a whole bunch of different virtual methods. And then you have to write a whole bunch of complex graphics code just to get that little simple circle inside of there correctly, right? Well, in the world of WPF, all you have to do is embed into the scope of the content control the new content, right? Now I'm going to actually show this happening in real time. Let's just see how this would actually look. This will also be an example of another little tool that I want to share with you. There's a great tool out there you can get for free on the web. It's called Xml, right? I love the name. Reminds me of Shazam for some reason. I'm not sure why. What Xml is basically just a very, very lightweight editor to go ahead and type in markup and then see how it looks. There's no C# code. There's no Visual Basic code. You're not worried about web services or whatnot. You're just trying to play around with markup to see how it looks and feels, right? Xml has a bunch of other nice things like a little color picker. We can go ahead and beautify the markup, right? Bunch of built-in example code snippets that you can paste inside of there. But back to what we're seeing. So notice that this is still the same button, right? a system.windows.controls.button object. But I've simply said I don't want my content just to be a blob of string. I want it to be this slightly more interesting collection of controls here. Right? So again, this alone is a great step forward. It really reduces the amount of times we have to subclass, because now we can just whip up any kind of content that we want. And if you have a skilled graphical artist, they can make that look a lot more pretty than what I just did. Okay, so now let's take these two classes, application and window, and build something. Now remember, for this first little example I want to show you, we're not going to have any markup. We're just going to do it all by code, right? Now let's just kind of analyze what's going on here in the code, and don't worry about trying to read every single thing. I'm just going to try to point out a couple of key pieces for you to get you thinking. Alright, so what I did with this first iteration is I packaged up everything inside of the actual application class. So you can see, here's my main method. When the main method starts up, I'm going to create one of my application objects. I'm going to wire up my events. Then I'm going to call the run method. Okay, very typical code for a WPF main method. Now in these event handlers, the most interesting one is happening in my startup handler. This is where I'm just going to make one of my windows. And I'll set up some basic little characteristics like the height and the width. Then I'll just call the show method. The other two event handlers, you can see what I've done here in my dispatcher unhandled exception. I'm just going to scrape out the actual error from the incoming event args. And whatever you do with it is up to you. You might put it in an error log, right? You might email the system administrator. This is just a standard way to catch any problems that you didn't see as you were writing your code. So no Zamel, right? If I were to compile and run this program right now, I would just get your basic, simple, topmost window. Well, we can clean that up, of course. Typically you're going to want a subclass window, right? So now I'll go ahead and just make a custom constructor. So I can go ahead and encapsulate all that startup logic here. And then that will also simplify what I have to do back in my startup handler. Now I'll just make one of my own custom windows as opposed to the window. Now, as I said, you could build an entire application using nothing but C# or Visual Basic Code. But it'll get pretty tedious, especially when you're working with some more of those fancy things like the animations and the vector graphics and whatnot. That can be a lot of code. So that's exactly where Zamel can step in for us. And when you look at Zamel the first time, there appears to be a little bit of magic here, and we know that there's never any real magic. So let me go to Visual Studio, and I want to show you what really happens to Zamel. Then I'll talk a little bit about some interesting bits of syntax. So I'm going to go to Visual Studio right now. And we'll go File, New Project, WPF Application. What happened to the Zamel app? Now I'm also going to be talking about just Visual Studio as a way to build the WPF program as well. Okay. So we looked at one approach where we wrote nothing but C# code. What Visual Studio uses is sort of like the middle of the road approach. Because believe it or not, you could also write an entire application using nothing but Zamel. There's actually a way to embed in the Zamel document real code. Now that's not recommended, but it can be done. And I'll show you that too. But let's just look at what we get through this code file approach. So over here in my Solution Explorer, you'll see that I have an application and a main window. But behind each one of the Zamel files is a relative code file. right? So if I were to look at main window.xaml, that's what I'm seeing displayed in my editor over here, right? In the markup, let me just go ahead and zoom that in for you. In the markup, you can see there is a XAML attribute called class. So what this is basically saying is that this markup is working in conjunction with some class called main window, and that would be in the code file, right? So there's main window right here. Okay. So now let's look at what happens to this markup. I'm just going to drag and drop over onto my designer, maybe just a simple button. Now let's make it a little bit bigger here. Now we can see how Visual Studio is authoring the markup for me. I just did a fresh rebuild of this computer, by the way. That's why all my windows are gone and whatnot. You pull up the property editor. So I could go ahead and grab this button, and I could start to make some visual changes to it. I could start to go ahead and, set background colors and foreground colors and whatnot. I could start to handle different events, right? So I might come over here and change the background color. Just something we can look at. And then maybe I'll change the cursor to be weight icon. So as I'm making all my adjustments over here, we can see that Visual Studio, I'll go back to this mode, is just authoring that markup for us, right? So there's my background color and cursor. Now I'll run the program just to compile it, right? So not too surprisingly, there's my application. Doesn't do much, but it's doing something. But the important part, the part that I want to illustrate right now, is what actually got compiled. So I'm going to go back to my Solution Explorer, click on Show All Files. I'm going to drill under my OBJ debug folder. Now, this is stuff which is more of a good to know for educational purposes situation. You're never going to want to edit any of these files because you could very easily break stuff. Every time you recompile, all that's going to be put together. But let's just try to connect the dots here. If I go back to my primary C# file, you see how main window is a partial class? And you might know what that is, right? In .NET 2.0, we got this partial keyword, which means that the class can be defined across multiple code files. Really useful for tool support. Well, you see this file over here, mainwindow.g.cs? That is created by the compiler, and inside of this partial class definition, you would find, for example, the declaration of your XAML elements. So there was the button I threw on there. And then inside of initialize component, which is called from your constructor, right? There is this code which is going to be loading up the binary XAML. Remember what we call that? We call that BAML. We can actually see that over here too. Mainwindow.baml. So look, right? There's my background color and there is my weight cursor. So all this markup, so all this stuff that we see back over here, and it certainly is not a lot of markup, but all that markup is going to be used to generate the G file and the BAML resource. And then this data is going to be packaged up inside of your compiled application. Right? So that's why we said earlier, you don't ever have to worry about shipping along all this XAML to the customer. It's all going to be packaged up inside of the executable. Now, thankfully, we have great tool support to generate markup. Even Visual Studio has some pretty decent support for all your basic stuff. Laying out a window, creating a dialog box. You could do all that in Visual Studio pretty well. And Visual Studio 2010 even has some better features that we didn't have at all in 2008. Like you might have seen, I used that little brush editor. There's also better support for data binding, but really Blend is where it's at when it comes to productivity for XAML. But in any case, a tool typically builds the XAML for us. That doesn't mean that it's not good for us to know how to go back and tweak it. So what I want to do here is kind of just walk you through some pieces of XAML syntax. And again, we'd be going into this in more detail in the full class. But let's just take a look at this code here. Okay, these are two different ways to describe the same exact button. Right? Up on top, I've described the button purely in markup. So the way that it works here is that every XAML element is going to be mapping to a class inside of some namespace, right? Some .NET namespace. Every attribute on the element will either map to a property or an event on that class. So we can see that I've given my button a name. I've decided on a height and a width. Here, the content is just a simple blob of text. But remember the other button with the graphic inside of it? Remember, content can be anything you want. And then I've also handled the click event. Well, down below, here's the exact same button put together entirely in C# code. Okay, so they're just kind of two sides of a coin here. Now let me just kind of touch on this topic. Remember that it is actually possible to build an entire WPF program without ever having any actual code files. Please remember, this is not recommended. It is supported, but it just wouldn't be a very clean separation of concerns at all. It kind of reminds me of back in the day when we had classic ASP, you know, big mismatch of script code and markup. Well, we can kind of do the same thing here. Now, let's just see how it looks just to get a better handle on things. Here is a XAML file that describes a window, right? Now notice that my window has as content a single button, okay? Now here's the weird part. This is the part right down here that would not be a recommended practice whatsoever. But there is this little element called a code element. And what we can do is we can embed in the XAML file within a C data section actual code, right? So that's basically the click handler for my button. Now I could also describe completely through markup the application. Remember, you don't have to have a visual aspect, right? So here's the application. We can see that in this version of my application, I'm just going to handle the exit event, which is inside of this code element. Okay? So at this point, what I basically have is I have these two XAML files. Now what the heck do I do with them? Well, the C# and Visual Basic compilers, they don't have any clue what to do with raw XAML. Right? They're just going to start throwing all kinds of crazy errors. But MS Build has some target files that can transform the XAML into the code equivalent. And that's what Visual Studio did in the background when I showed you those little G files. Okay? So if we had a build script, I could pull up MS Build right now in the command prompt, point it to the location of my two XAML files, and lo and behold, I would have a true blue .NET executable. Now, let's look at some more practical parts of XAML. This is the part that you need to understand the basic syntax, because you'll certainly need to go back and tweak things every now and again, no matter how good a tool might be, such again, you know, Blend or Visual Studio. You might want to go back and optimize the markup. Maybe you just find it quicker to just retype something as opposed to using all the visual tools. And there are a couple of aspects of working with XAML that are a little different than your typical XML document. So that's the part I want to focus on here. And the first thing I want to do is I want to talk about these weird, mysterious XML namespaces. Okay, these can make people kind of wonder, what the heck's going on with this? As a very good rule of thumb, every single XAML file that you create in the root element will always have these two XML namespaces. And I'll tell you why. The root XML namespace, the one that ends with the word presentation, that is basically a way to import through markup all of these core WPF.NET namespaces. So that little string, that actually means something, right? If you were to look inside of the WPF libraries, Windows Base, Presentation Core, Presentation Foundation, you would actually find some assembly level attributes that say, hey, if I find this big string, that's going to be mapping to these different .NET namespaces. And that's why if I were to go to my Visual Studio Editor, let's go back here. I did a drag and drop operation to get that button on here. But I could also do it just through typing directly in the editor. So if I were to come back over here, right? So you can see I can start to get some IntelliSense so it knows what a button is. Well, the reason that it knows what a button is because I have that root XAML namespace that ends in presentation. Because this string is effectively bringing in system.windows.controls. Now the other one that has the X tag prefix, see how that ends in the word XAML? That is basically giving you access to what you can kind of consider XAML keywords. So if we're trying to get anything in that XAML namespace, we got to prefix the letter X. If I can just go backwards, did you notice over here how the code attribute said X:code? Well, that's because the code element is part of that XAML namespace. Another good reason for tool support, right? It'd be pretty tedious if we always had to remember which tag prefix to use for all these different things, because in many cases, you might have a production level WPF window. There's going to be a lot more of these little mappings beyond the two that we see here. It's very common to define your own tag prefixes if you're trying to point to controls in a custom library, for example. So if we have a good tool, it'll generate that markup for us through drag and drop operations. Here's an example of where you might put together your own XML namespaces. Let's say, for example, you wanted to describe in markup something in the system namespace of MS Core Lib. Well, you can do that. You just got to build up a tag prefix. So check that out, right? You see that little CLR-namespace? Okay, that's mandatory. That is a token that says, I'm trying to map to some namespace in an assembly which is not part of that default set I get from here. Okay? If you're trying to define something in XAML which is part of the current program, it just happens to be in a different namespace, you do a very similar thing, but you don't have to say assembly equal, as we did for MS Core Lib. Now, little FYI for you folks, where would you find that very, very useful? Again, you're trying to, one of your coworkers built a WPF control library. You want to reference it in your project and then describe one of the objects in markup. First thing you got to do, you got to make a tag prefix. In this chart, these are some of the other things that we get from that XAML namespace. Remember, because they're all coming from that XAML namespace, we typically always want to prefix that letter X in front of the element. There are actually a couple of shortcuts in some cases, but generally speaking, if you want any of these items in your markup, you got to do the X:. Now, for this little video tutorial, I'm not going to get into all these pieces here. I do just want to give you a taste of what you can do with this Zamel namespace. And let me just skip ahead for a second, and then I'll go back. But let me just show you one example. I'm going to actually copy this to my clipboard. And I'm going to go back to Xaml. And I think, let's see, let me do this. Then I'll put him here. Sorry, just doing a little bit of cleanup. There we go. Okay, check it out. What I've just done is I've defined an XML namespace. Let me just zoom this in here. Okay, called CoreLib. Now, CoreLib is pointing where? The system.net namespace of MS CoreLib. Okay, that part we already talked about. But here's the idea of some of these XAML tokens. You see here where I say x:static? This is actually something called a markup extension. You see how everything inside of that double quoted string is encased in curly brackets? That is a markup extension. And the easiest way to think of these markup extensions, they're a way for you to get a value which is not known until runtime to assign it to an object. Classic examples, data binding, right? Data binding is all about markup extensions. Another good example might be a custom control template, right? Other good examples could be object resources. Well, here, what x:static does is it says, hey, I'm trying to invoke somebody's static property to get the data that I need to set the content of these labels. Well, remember my tag prefix, right? So that really is saying system.environment.machine name, OS version, and processor count. So up here, right, I'd be able to see that sure enough, I'm displaying real-time processors, version of Windows, and the name of this computer. So pretty interesting stuff, right? I'm able to go ahead and invoke static items through markup. Let me flip back to where we just were. Alright, so that what I just showed you guys there was I was trying to illustrate one of these little XAML tokens in action. So we just looked at the static. Okay, plenty of other ones you can get into as well. And in the full class, we do kind of go through each option so you see what's possible. But believe it or not, it's actually useful stuff. Now, here's the first bit of syntax, which is a little different than your typical XML document. This is one that's really important to know about, right? Did you notice here when you're defining an element, everything seems to be captured as string data. Height equal quote 100 quote, right? Well, certainly you can probably already imagine something has to be happening here because the height property, it doesn't want a string, it wants a number. Well, WPF is a whole bunch of built-in type converters that just work in the background. So there is something which will actually take that string and parse out the correct underlying double data type, right? But if you can capture your data as a simple string, go for it. Sometimes it's not that easy though. What if you said, I'm trying to define something in markup, and I'm trying to set this property, but the trick is, the value of the property, I can't capture it as a string, because it's a complex object all by itself. Well, then we have a special syntax for that, called property element syntax. Here's the template you can follow, right? So here when I say defining type, I just mean the thing that has the property you're trying to set, like a button control. But now here's the property element syntax. Notice how I've defined this internal scope. Defining type dot property on defining type. Okay, that's the property element syntax. So that might say, for example, button dot background, right? I want to change the background color of this button. And then inside of there, you would put together your complex brush. Here's an example. Now, this graphic here also accentuates why I'm not a graphical artist. Not a very good looking button, but it gets the point across, right? I want to change the background color of this button, but I don't just want to pick between a solid color. I want to have a gradient brush. Well, I need to define a whole sub-object of type linear gradient brush. And I can't capture that as a simple string, so I'm going to use my property element syntax. Now this is just an example. It doesn't have to obviously be a brush. That could be any complex object that you're trying to put together. Here's another bit of Zamel syntax which is pretty pervasive. Attach property syntax. Here is the short answer. You will really care about this when you're defining layout systems, right? Grids and dock panels and canvases. They all make use of this particular syntax called attach property syntax. What this allows you to do is to define a parent container, like a dock panel, and then say, all right, so I got this dock panel that has these 10 different things, and I have to decide where to put them, right? Put this one on the top, these 4 on the left, this one on the bottom, etc. So using attach property syntax, a child element can basically tell the parent where to put it. So here's an example of this. And again, please don't try to read every line of markup here. Just kind of get the bigger picture. I've defined a window that has as its only piece of content a layout manager. And the layout manager is this dock panel. Well, the dock panel has a set of items inside of it, right? I got a couple of different labels, and I got a button control. So notice here how all my labels are telling the parent where to dock it, right? So I'm just doing your basic top, left, bottom, right. The button, on the other hand, doesn't say where it wants to be placed. Well, look again at the top defining part of the dock panel. You see that little property called last child fill equal true? Well, that's actually the default value anyway, but I just wanted to type it out so you could see it. This particular property says just that. Whatever the last item in the dock panel is, he gets the remainder of the space. So that button, his size is not dictated by a height and a width, it's just the remainder of the dock panel, right? So if I were to stretch out that window, make it bigger and bigger, the button will also grow or shrink based on the remaining size of the client area. So just a little example of this attached property syntax, and it also gives you a taste of layout managers. You know, in the full WPF class, we have a whole chapter dedicated to layouts and controls, and throughout every single lab, you get a chance to tinker with all these things. And then here's the final piece of odd Zamel syntax, which I actually already showed you. That was the idea of a markup extension. Remember, the short answer here is that markup extensions give you a way to assign a property to a value which is actually not known until runtime. Data binding, invoking static members, working with templates. These are all prime candidates for working with these markup extensions. Remember what the telltale sign is for these, right? It's going to be encased inside these little curly brackets. So we're still setting a string value, it looks like, but inside of there we're going to have these curly brackets, which actually refers us back to a markup extension, right? So there are many practical places where these things are downright mandatory. I already showed you, for example, this, right? That's the static markup extension. All right, so now, to kind of wind this down, and get you on your way. So we've looked at, really at this point in our video, we've really looked at two different approaches that we can go to build a WPF program. I could go all code, I could go all XAML, but then as we saw earlier through the Visual Studio example, Visual Studio prefers the middle of the road approach with these code files, right? And that's also exactly what we get when we make a brand new project in Blend. So remember how that kind of works in the background, right? The markup that you type, that's where we are primarily concerned with UI descriptions of things. And again, it doesn't have to be UI, but that's what we typically find in a window. And then the code file, that's where we're concerned about all the programming logic, right? Now I showed you back in Visual Studio, as we're typing away with all of our markup here, right? Let me get rid of my undefined button. There we go. So as we saw, when I go ahead and, let me get that a little smaller, there we go. When I go ahead and type in all this markup, or the designer does it for me, when I do a recompilation, that's where we will find that we get our G files. As we saw, that's where we would go ahead and get things like member variable declarations, right? So we get all of our little controls defined here. That's also where we find that the BAML will be read in dynamically, so we can go ahead and make our controls look the correct way. Now again, that's stuff that we don't typically care about too much to view, but always handy to know how it works in the background. From a more practical day-to-day point, we're just going to kind of be concerned with the primary XAML file and the primary code file. Now, when it comes to event handling, this also kind of comes into play here. So let's imagine that I wanted to handle an event for this button. I'll go ahead and delete this guy, right? Well, you can do that a couple of different ways, actually. If you want to handle the event through markup, so I'm just going to handle the click event here. You see, as soon as I type in the event name and then hit the equal sign, see that little bubble that says new event handler? Well, if I just were to press the enter key right now, it'll auto-complete a name of the handler for me. And more importantly, it'll update my code file with the handler. So I can just do something. At least they didn't change messagebox.show, right? So sure enough, click the button, handler is called. But I can also handle events in a different way. Let me just go ahead and delete this. Much like Windows Forms, the Properties panel has an Events tab. So if I want to handle a click event, I could just type in the name of a method right there. And that will just wire me up the same exact way. And then the tool will go ahead and put that back in for me. So then when you kind of think about all the moving parts here, your XAML file that we see over here, right, that will go ahead and generate that G file, which is merged together with your partial class. So we got one actual class, and then the BAML resource is going to be hydrating the look and feel of all these objects, right, to make them look the right way. Same thing for the app class. If I were to double click on the app.xaml, well, remember that we never see the application. So the XAML file is pretty empty right now. Typically you'd find in here a whole bunch of object resources that you want to reuse in your application. But notice how he does have a class that we see over there. So there's your application. So that is what I wanted to say today, my friends. I'm just kind of getting you thinking about this WPF programming model. What I was hoping to show you in this little overview was just kind of like those real basic foundational pieces on what exactly is going on with a WPF program. What does XAML really mean? And this is just a foundational first look at a very large topic. Maybe if things work out in the future, maybe I'll see one of you in one of my classes sometimes. Then we take this foundation and then we go out and do all the fun stuff, right? We work with data binding, we work with custom templates, we work with animations and graphics, and we build a bunch of different applications. But this right here, at least, I hope will give you a pretty good flavor for what's going on in the background. So thanks for logging on in. And let me just throw this up real quick too. I'll put up my email address in case anyone wants to fire me off an email. atrolson@intertech.com. Again, my name is Andrew Trolson. So again, thanks a lot, everyone. We'll talk to you later.